although I sometimes come to WPI for other activities. I find this to be very interesting, especially following Dick's comments, opening remarks. I was sitting in the back and I was thinking, well, what am I going to say now? It turns out that some of the activities that we are doing are very much in line with what you just heard, except we come at it from a different point of view. I represent the Department of Homeland Security Science and Technology Directorate. How many of you are familiar with DHS or even at that S&T? By show of hands. Okay, that's usually the general approach. Not a lot of people understand that. So let me start off by telling you that the Science and Technology Directorate for DHS is very much similar to what DARPA is to military. The time horizon for some of the activities that we do at S&T range from 0 to 3 years, 3 to 5, and 5 to 8. And if you convert that to the research spectrum, R&D, that's anywhere from transitional technologies, from actually, if you look at it from the left side, basic research all the way to transitional technology. So with that in mind, what I would like to share with you is our views of some of the activities that we are doing in pursuit of location tracking, not for the mass population, but for a special breed of people that we refer to as the first responders, and we're there for them to save their lives. Next, please. Before I do that, since you don't know much about S&T, this is our current organization. There is an undersecretary from S&T, and she, Dr. O'Toole, reports to the secretary, Napolitano. There are 6 divisions, and I'm in one of the divisions, and I manage a portfolio that is referred to as the Preparedness and Response. And you'll see why Preparedness and Response in just a moment. Next, please. The end user community that we deal with, that I deal with, is the first responder community. You see some of the statistics there. If you do all the permutations that you see there, on a good day, when it's sunny out there and so on, the total numbers will range anywhere from about 1.5 million all the way up to probably about 3 million. Just as a point of reference, when you think about the firefighting community, realize that about 80% of the firefighters are volunteers. And then you've got 20% who are professional firefighters. Furthermore, when you look at the incidents that happened, all the way going back, for example, right here, the Worcester fire in 1999, 6 firefighters lost their lives. The cold storage facility, if you know about that incident, the 6 firefighters went into this cold storage facility, got a call that there was a homeless guy in there. They went in there to save the guy. If you look at the pictures of this cold storage facility, it's not a complex structure. It's very square. It's got a couple of different brick walls inside. 6 go in there, and there's smoke and haze. They get disoriented, and they cannot find their way out. After all the incident, the 6 guys died, and it turns out there was no homeless guy in there. When you look at what happened, you find out that these guys were about 100 feet away from an exit. Just couldn't find it. Furthermore, if you look at the structure, there is no maze or anything. It's just very simple. So starting with that, people started to make some noise about we need to figure out a way of locating and tracking our first responders. And the usual stuff. We can send a man to the moon, how come we can't track these guys in the building? Fast forward to 2001, 9/11, and you know what happened there. A bunch of people died. Some of them ended up going to the same location because some of the commanders didn't know that they had people in the same location. So that became a big problem for us to look into in 2005 and 2006. Again, looking at these numbers, the number of communities involved, and the number, 1.5 million, 2 million users, when you compare that to, for example, Verizon's subscribers, that's very small. But I think you have to think about the weighting factor that you put up that, because you're dealing with lives. So it's important for us, from that point of view, to fund technologies and go after algorithms algorithms, hardware, software, sensors, etc., to help us to locate and track these firefighters and the first responders. And when I say firefighters, I use that as an example, because we're also looking at law enforcement as well. Next, please. So, for us, whereas in the case of what Dick was talking about, mass population, these days, you want to know about where you are, right? Because if you have the GPS, I mean, he can help you and you know exactly where you are. But if you don't have GPS, you want to know about where you are. In our case, you want to know exactly where you are when you go into a building. Because when you talk to the first responder community, for them, for example, the firefighting community, they want to know the floor. Typically, you're looking at 10 feet. Translated into the metric system, 3 meters. So that's altitude. If you're outside, you've got the GPS unit with you, easy piece of cake. Everybody can do that. But when you go inside a building, that's when things get really complex. The other thing that I'd like to know is, if you go into a building, like for example, this floor plan, you've got concrete, steel, glass, and everything else, and the floor structure changes. They want to know who's on the other side of the wall, so they can get them out. So for us, the problem is exactly where are they? And while we're at it, again, Dick was talking about some of the latest, newest things that go with location-based systems. For example, how are you doing physiological monitoring? Although I'm not going to talk about physiological monitoring, let me tell you that that is also another major program within my portfolio as it relates to the first responders, because we are also interested in figuring out what is happening to them, and not so much on the single individual speeds. For example, what is your heart rate, your pulse rate, your perspiration, and so on. We want to fuse that information and get out of that some actionable alarms. That is to say, his left arm is getting numb, and his heart rate is going up, and he's sweating, and so on. Does that mean he's having a heart attack? Can we get him out? Now, if you take that problem and kind of scale it up to the mass population, well, there are all kinds of commercial applications for that. But let's focus on location tracking. So for us, this cartoon kind of depicts what happens when there's an incident. Typically, you get about a couple of fire trucks going to the site. People go inside, and so that's kind of like the CONOPS, the concept of operation for these guys. The requirement that is really challenging is that these first responders already carry a large amount of equipment, which adds up to anywhere from 40 pounds to about 80 pounds. So you're looking at the air bottle that they carry, the gear, the suit, and the gadgets, and the pass devices, and so on. One of the biggest requirements from them has been they don't want to carry anything that's heavy. Next, please. We also deal with some of the community representatives. There's something called an IAB. Anybody familiar with that? It's an interagency board composed of DOD, state, and Homeland Security. And participation, it's got about over 1,000 members, and they constantly promote their requirements for location tracking for the first responders. And they've been a major force in kind of forcing us to put this program together. And that kind of explains what they're asking for. So for us, the biggest requirement is the altitude. Okay? Anybody can give you X and Y, but I think if you look around, altitude is the challenging part. So that has become one of our major requirements. Next, please. So, with all of what I just said, it all translates into we'd like to have a capability to locate and monitor, track these people when they go inside buildings, underground, et cetera, et cetera. By the way, we work very closely with our friends on the DOD side of things, people from DARPA as well, because they're also interested in the so-called field force tracking, underground, and so on. So what we have done is we've taken everything that I just mentioned, plus a lot more, and turned it into functional requirements that you see up here. It's a huge list. I'm not going to go through that, but just to give you an idea of some of them. Location tracking accurate to 3 meters or less in X, Y, and Z. For us, the mission requirement, the sortie, the kind of concept of operation is about a couple hours. Again, they talked about this energy and battery power and so on. It happens to be another one of my programs that I have in my portfolio because we also realize that these guys constantly go in and out. They don't have time to come back and recharge their batteries. So we are looking at new ways of power management and energy efficient devices. One of the other requirements that I mentioned to you is that our users don't want to carry bulky equipment. So we made a requirement that the device has to be about 2 inches by 4 inches by 6 inches, at least the going-in proposition. Now, it's not for the mass population where you can put it on a cell phone, but we're trying to push the R&D community to think in terms of miniaturizing these systems so that eventually they could end up into an iPhone, a BlackBerry, or even anything smaller, maybe a watch. And some of the other requirements that you see there. Again, one of the most important requirements for us has been we do not want to depend on having knowledge of what the building looks like. And I'm not talking outside the building, I'm talking about inside the building. So one of the other things that we have done is we've started a program to develop a visualization engine, if you will, so that it will operate off the cues that you get from the radios. The guy goes into the building and says, hey, I'm by the fire door, and you know his location, and you can kind of muck it up. I'm going up the stairs, I'm in the elevator shaft, etc. So you can muck it up quickly. And so what we have done is, with the limited amount of dollars that we have tried to identify these technological nuggets that are kind of challenging and get the research and development community to think about solving those problems. Next, please. One of the things that we did, took advantage of our SBIR program and developed a prototype visualization engine. And this system generates the internal floor plan of the building in a three-dimensional view, as you see, on the fly, based on the cues that are coming in. And it also has the ability to take a two-dimensional blueprint of the floor plan and generate a three-dimensional view for you. We're very happy with this because there are a couple other companies that are kind of getting into that market as well. So what is the implication? Well, we need this for our system. But I believe the implication is that as you think about location-based tracking and monitoring, etc., you have to kind of approach these things as if I don't have anything. Can I rub the bottle and the genie comes out and says, here you are, you know, a cubicle on this side and room number, etc., etc. So these are some of the things that we're trying to push the R&D community to think about. Next, please. We developed a prototype unit of our system about 3 years ago that you see up there. From a marketing point of view, ended up calling it the cocktail solution. And you can see the complement of the sensors that we've included in there. The prototype is big. It's about this size by this size and about 3-4 inches big. But that's just the prototype. So it includes the GPS chip in there and some of the other things. For altitude, we use an altimeter. We also use an ultra-wideband. There's an IMU in there. Everything that you've seen before. Except we went at it from sort of, our dollars are small, let's put it all together and play with the algorithms. You need a column filter in there to do the filtering for you and give you your real-time location. Next, please. We did some testing and experimentation with the units that we had. And it took about 2 years. We have not solved the problem entirely. There are still technological challenges that have to be solved. As I mentioned before, when you kind of summarize everything that I just told you, with our user community, cost is also an issue. And I think there's a parallel with the mass population. I think when you look at it in terms of getting it out to the population, whether it's a service that you have to pay for, people don't want to pay too much for these things. So our approach has been how could we minimize the cost for these things? Because our user community does not have the dollars to pay $1,000 or $1,500 or $2,000. They're looking at sub $100. And I guarantee you with the mass population, they're probably looking at maybe dollars. So that kind of drives your business market as far as whether it should be a service-based system or whether you buy the system, et cetera, et cetera. Some of the things that we found for our user community, size, weight, typically people talk about size, weight, and power. Well, for us, it's automation. And I guarantee you, again, for the mass population, it's almost like the typical computer users. They really don't want to be bothered with fixing things. They just want to turn it on and it has to work. Same thing for us. So you can see some parallels in here as well. Like I said, cost is a major issue for us. Reliability, stability, and robustness is also a big thing for us. Next. So we took our prototype and turned this into a program of record at DHS. So right now, this entire location-based tracking system, which we refer to as GLANSER, because everybody loves to have an acronym here, is the program of record that is trying to solve this problem and then turn it into a product. Thanks, please. I was talking to somebody this morning about how do we operate. Well, we go through the BAA process as well, just like Doc and some of the other R&D communities. At the BAA last year, detailed requirements, it's public, it's on the web somewhere, if you can locate it. You can see some of our detailed requirements that we're looking for, pretty much along the lines of what I just mentioned to you. Put our BAA out there, next please. Ended up selecting 2 companies, competitive. One company led by Argonne Science and Technology, another one led by Honeywell. Each one has a different solution, but when you put them all next to each other, the similarities are just unbelievable. So people are going at it from a different way. Our goal is to have a product that we can put out for the first responder community. Next, please. Here are some of the things that we are trying to get to. Remember I said 3 meters in X, Y, and Z? We are trying to get it down to about 1 meter or less. If you think 3 meters is tough, wait until you get to 1 meter. It is absolutely tough. I mean, it's not linear from 3 meters to 1 meter. Exponential is an understatement. And when you combine that with the cost that you have to pay for these things, I mean, it is just tough. But you know what? We have to push the R&D community, the universities and industry and so on. So that's what we're looking for. The other thing is the cost reduction. As I mentioned, some of these units, the early prototype, we priced it at about $2,500. That's a no-no. I mean, no. So here's the dilemma. You want to use a good IMU that is good, small drift rates and so on. It's expensive. Right? If you want to use a good IMU, you get good performance, but it's expensive. If you want to use a cheap IMU and cheap units, well, performance is something else you have to worry about. So where's the sweet spot here? And that's a big challenge. Some of the other things that you see in here, cost, like I said, form, fit, function. Our goal is right now to get it down to about 2 by 4 by 6, but at the same time, we're pushing these guys to get it down to a smaller device. Hopefully, we'll get it down to maybe one of these little devices that we used to see on Star Trek movies and shows. Next. So here's the way we're going about our program. The program was put in place, this program of record last year. We selected these 2 companies. We are about to do a significant program review as a milestone this week. And in about a couple weeks or so in July, we are going to do our first test in one of the buildings at Honeywell in Minneapolis and another building in Fairfax, Virginia, where Argonne is located. And then we'll end up going to U.S. Fire Administration, where we will use one of their buildings to do some testing with the firefighters. Past that point, depending on the results that we get, we may end up spinning the first version of this, even though it's going to be a big unit, so that we can get it out to do more testing with the user community. And then past that point, we go through the CDR and so on, the standard steps that we have to go. Our GLANSER program is a multi-year program. That's the way it's been structured. And our goal, hope, is that in about 2 more years, we will have a product that we can put out. Now, That's what we're doing at DHS. That's what S&T, Science and Technology, is doing for our user community. I believe that there are so many parallels between what we're doing and what you will hear today, starting with Dick and some of the other speakers, that all point to this notion that location-based tracking, information, knowledge, etc., is becoming the new wave. If you just, let me leave you with this thought. If you look back about 10, 15 years ago, when the first GPS units came out, they were huge. And they were using them for surveying, landmarks and other things. About 5 years ago, you've got a number of companies that are putting out these 3.5-inch, 4.3-inch, et cetera, et cetera. The cost has gone down significantly in the past 10 years, 5 years. You can buy a 3.5-inch unit for about $49. I contend that given another 4 or 5 years, everybody is going to move into this location-based information system network, whatever you want to call it, that you can even use your watch to figure out where you're located. And I think everybody is moving towards that market area and some kind of a business model for the mass population as well as law enforcement, military, homeland security applications, and so on. So that's the trend that we see, having been involved in this kind of activity environment for the past few years and talking to various people. It's going to be a healthy market. That's everything points towards that orientation. So let me leave you with that. Thank you.
We probably have, just before we introduce our next speaker, is there any quick questions for Jalal before?
I have a question.
Yes.
There are all these requirements that you have carbon monoxide detectors, etc., for like fire issues. Why couldn't there be requirements like that you can have little transmitters that the firefighters could locate themselves?
You mean as in breadcrumbs?
Yeah, something that essentially helps. I don't exactly know what it would be because I haven't thought about the business model. But why couldn't there be?
Right. If I understand your question, one of the things that we talked to our user community was whether they would be willing to put up these so-called breadcrumb systems. And breadcrumbs come in different forms. Some of them are really crumbs and breadcrumbs, and some are bread loaves. Their initial position was that they did not want to be bothered, spend the time to put things up there and so on. There are breadcrumbs that you have to put up there and make sure that you know exactly where they're located so that you can follow, do the triangulation, if you will. There are other systems you can just drop and use as a leader. As of recently, I'm glad actually that you asked, I've got another small program where we are developing a little breadcrumb system which is about the size of a dime, about 1 inch in diameter, and about 1/2 inch in thickness, that can be dropped automatically, and it's got some smarts in it, and it operates as a relay. And our user community seems to be okay with that, again, as long as it does things automatically. The other issue is that many communities, especially big cities and so on, with the new construction, are moving into this era of instrumenting the building. Whether it's the wireless systems or structural stability, health maintenance, and so on. Some other areas within DHS in our organization are also pushing to turn that into a standard, impose that as a requirement for new construction through the American Architectural Society. Yes?
On the same line, why wouldn't you require, for instance, that the city halls, instead of having a 2-dimensional plan, have a 3-dimensional plan of buildings that could be accessed?
Right. Easier said than done. I think there's a cost involved, and so you have to think about what is the incentive for the owners to do this. One of the thoughts has been that the incentive would be that their insurance premiums would go down if, for example, they offered their 3-dimensional, the CAD systems, the CAD models of their buildings, and provided that in a database somewhere for emergency requirements. Having said that, if you go to the city of Chicago, you will notice that the city has got CAD models of most of their buildings in the downtown area. And again, everybody's moving in that direction. Chicago is the first to do that. New York City is looking into that. Some of the other places are also looking into that. So again, We identify the issues, we put them out there. People like yourselves ask the logical questions. Well, why didn't you just put your CAD model somewhere so that people could use that? And boom, boom. And